Greetings and salutations, everybody. How's everybody doing? Hope you're having a splendid day. This is Jacob. I'm back with another interesting problem. This time it's a travel time optimization problem. And today I'm debuting my new Slick 2025 logo. I hope you all like it. So let's get right into it, shall we? A man is trying to minimize the travel time between himself and an offshore island. The perpendicular distance between the man and the island is 6 kilometers, and the distance between the island and the shore of the beach is 2 kilometers. The man's swimming speed is 4 kilometers per hour, and the man's running speed is 8 kilometers per hour. The question is, at which point does the man have to start swimming in order to minimize the travel time to the island? Pause the video if you'd like to give this problem a try. And when you're done, smash the play button. So let's get right into it. The total travel time is the time it takes him to run plus the swimming time. Okay, let's call x the distance that the man traverses running before he starts swimming. So the total travel time is going to be x over 8 plus the hypotenuse of this triangle right here, which is square root x minus x squared plus 4 over 4. And that's the total travel time. So we're going to have to minimize this travel time. So how are we going to do this? Through calculus. You take the derivative of this function with respect to x, and you equalize it to 0. So the derivative of this function is going to be 1 over 8, and the derivative of this complex function, we're going to use the product, the chain rule, and the power rule, and it's going to be minus 1 over 2 times 6 minus x squared plus 4 to the power of minus 1.2 times 2 times 6 minus x all over 4. And this simplifies to 1 over 8 minus 6 minus x over 4 times the square root of 6 minus x squared plus 4. And we'll equate this to 0. We do the calculations, and the equation simplifies to 6 minus x squared equals 64 over 48. Since the first part of the equation, we square it, 6 minus x is the same as x minus 6. So we'll take both conditions. So it equals to 6 plus minus 8 over square root of 48. We try the first one. 6 plus 8 over the square root of 48, which equals 7.15 kilometers, which is outside of the bounds of the problem. So we'll eliminate this case. So the second case has to be the solution, which is 6 minus 8 over the square root of 48, which is roughly 4.84 kilometers. So we plug this value into our initial equation, and it becomes 4.84 over 8 plus 6 minus 4.84 squared plus 4 over 4, which simplifies to 4.84 over 8 plus 2.27 over 4, which is 1.17 hours. So when the man traverses 4.84 kilometers running and then he starts swimming, he'll take 1.17 hours to get to the island. So let's verify that this is the minimum time. Let's take the other two extreme cases where x equals 0. It's going to be the square root of 6 squared plus 4 over 4, which is 1.58 hours. So if he starts swimming immediately, he's going to take 1.58 hours to get to the island. Now we equate x equals 6. This is going to be 6 over 8 plus square root of 4 over 4 is 6 over 8 plus 0.5 equals 1.25 hours. So if the man waits until the last minute until he starts swimming, and it's going to take him 1.25 hours to get to the island. So we've verified that the minimum time he can get to the island is 1.17 hours, and that's your answer. So yeah, that was a pretty nifty calculus problem. Very interesting optimization problem. I have many more problems like this in the pipeline. Many problems of various kinds. Calculus problems, differential equation problems, algebra problems, logic problems, geometry problems, probability problems, lateral thinking problems, which I'll be making in short form videos, YouTube shorts. So I hope you had fun solving this problem. So yeah, that's it for me. And I'll see you guys in the next video. Bye-bye.